students are struggling with audio in the chat.
No worries. Okay, guys, we're not quite ready to start yet, but you know the drill with Maths 24. There is 2 questions. There's an A and a B, and I would love to see who can get the closest to getting to 24. Hello, Lasedi. Hi, Tebogo. Hi, Keithan. Who can get closest? I always like to try by just adding the numbers up. So 8 plus 8 plus 4 plus 2, I can get to 22. Now that's getting me close to 24, but it's not getting me there yet. Who can get me there? What would get me a little bit closer than 22? Maybe if I could say 8. Let's see, 8 times 2, maybe 8 times 2 gives me 16, and then 16 plus 8 gives me 24, but now I haven't used all the numbers, so unfortunately that doesn't count. So who can get to 24 for the red one, for A? And then more than that, who can get to 24 for the blue one? Like I said, 8 plus 8 is 16. Take away 4, which is 12. 12 times 2 is 24. Micah, you are the winner for that one. Roberto was just behind you, Okay, let's try and do the blue one now. Can we get to 24 using the blue card? So we like to, for those who are new, and there are probably a reasonable number of you, we use this game to just get our brains going, and it's called Maths 24, and we try and get to 24 using just these 4 numbers. So I'm going to give another minute or so for someone to get us there. What can we do to get to 24? So if I said 7 plus 2 plus 1 plus 3, I'm still far away from 24. So Lasedi, 7 times 3, which is 21. 21 plus 2 plus 2. You've got close. Oh, I think 7 times 3 plus 2 plus 1. Let's have a look. So 7 times 3 plus, yes, you've got it. Okay, Lasedi's got it. So you just go 7 times 3 is 21, and then you just add the next 2, and then you get 24. All right, well done. That was a good, a nice way to start. And I hope that each time we do this, we get a bit better. I'm going to start bringing out the 3-dot cards one of these days, because you can actually make these harder. And I feel like we're starting to get them relatively easily. Okay, let's do the admin announcements. So Miss Anya, who is my co-host, my chat, ninja, she is going to just tell us about some admin and announcements.
Right. Hi, everyone. Welcome to tonight's lesson. Just while I'm chatting, if this is your first week with Watobe, or your first lesson rather, just let us know in the chat, send us a thumbs up if this is your first lesson tonight or this week. And then, yeah, nice to see you all again. Just remember, from my side, Wednesdays are fun quiz nights. So at the end of tonight's lesson, please stay on, especially the new peeps. I'm going to send the link to the quiz in the chat. And basically, you have to be logged into your Watobe account to do the quiz. So last year we used to do it on the app. Now we do it on the Watobe site. So, but if you know the drill by now, it should be straightforward. So once at the end of the lesson, if you have the link and you're on, you can hop off the call. Yeah, and I think, yeah, just a reminder, next week Monday is a public holiday, so no class next week Monday. You can hop on the call, but Sir and I will definitely not be there. Yeah, I think those are 2 big calls from my side. So
yeah, so basically, yeah, Monday's a public holiday, so we won't be here. But as I know, some of you, look, I think some of you may be done with school, but there is class on Wednesday. And so just to make you aware, but Monday there's no class. And basically, when we go to do the quiz this evening, once you're done with the quiz, you're done with the lesson. You don't need to come back. And that's mainly for our newbies, but you know, or somebody who hasn't done the quiz before. I think our regulars know that by now. Okay, are there any, before I go to the lesson, are there any other general questions or comments from the students? I'm looking at the chat and I just want to pause for a second before I go. Any comments or questions? Okay. Atando, go ahead.
Miss A, why do you say that when we go into, like on Monday, because it's a public holiday, why do you say that we can go into the lesson, but you won't be there?
It's like, no, it's like saying there's school on a Saturday. Like you can try and get into school, but there's not going to be any teachers. So it's just a joke. So there's no lesson. It was just a joke. All right.
Yeah, no, it's like a figure of speech. You know, when you say one thing and then it sounds like one thing, but it's almost got another meaning. So what Miss Anya was meaning was basically there won't be class on Monday.
Okay.
Yeah, no, it's a good comment. Trevor, yeah.
So I want to ask that since, well, like every day we normally do we normally do classes not classes but activities for every topic, because we're normally using the Watobe app, and since we're doing quizzes on every Wednesday for the Watobe website, why don't we normally do activities like for topics of maths?
So you're saying you want more activities about the stuff that you're covering or the other topics? Is that what you're saying, Trevor?
Yes,
so we are working on that at the moment, Trevor. We're definitely working on that moment. I can't say anything right now, but they're definitely working on that. So guys, I'm going to take some more questions in the middle of the lesson. But for now, I do want to just get started. But I see all those hands and I will give some more time for general questions later in the lesson. Okay, I just want to quickly today, the main thing today is going to be making sure that we can add and subtract and multiply and divide fractions. And we're just going to practice that. We're also going to practice 3 sub-skills that we practiced in the last lesson. And the one sub-skill, in fact, let me show you those 3 sub-skills. They are here. Is equivalent fractions. So we're going to practice a bit more about equivalent fractions. We're going to practice a bit more about common denominators, and we're also going to practice a bit more with improper fractions. So that's going to be the main ideas. Now, that's all recapping what we've done previously. But, you know, I think it's important that we really get these basics and ideas consolidated. Now, I just want to remind you, actually at the beginning, actually, no, you know what, let's start with an actual set of questions. Let's start with these sets of basics. We finished the last lesson, and I want you guys to start today by trying to do each of these. So question 1, well, let's say call it A, B, and C. In A, number 10, you have to work out what the missing number is in each of these.
Sorry, sir.
Yeah.
Can you just zoom in a little bit?
Okay.
Yeah, that's already a great up. Thank you.
Okay. And then in the second one, what you need to do is you need to look at the denominators and you need to find me the lowest common denominator. So I'm going to leave it on just those 6 questions for now. So we're going to have basically for this A10, A11, A12, and B10, B11, and B12. And I want you to put your answers in the chat because this is a foundational skill that we need to have for later in the lesson. Okay, over to the students. I will give you 3 minutes to do that. So from minutes past 5 to that point. So 3 minutes. So what do we do in B? In B, you need to find the lowest common denominator, and I've highlighted the denominators for you. So for B10, what is the lowest common denominator for 15 and 5? That's what I'm asking for. So B10's answer, what's the lowest common denominator for 15 and 5? I've given you two fractions here, 13 over 15 and 4 over 5. So I'm just checking you know how to find the common denominators before I move on.
And then, so just to jump in here, because I know, especially in Afrikaans, if you do maths in Afrikaans, like our abbreviations sometimes make sense, sometimes they do not.
Yeah.
But like, for instance, even when I was still tutoring and teaching maths, a lot of students tend to get confused with like LCM and LCD. It's basic, it's the same process. It's the exact same process. Lowest common denominator just refers to fractions. And remember, just one thing I want to remind you of when you do the LCD or the lowest common multiple of numbers, think of pants. So both numbers need to fit into that size pants. I'm like doubting my own English tonight, but
No.
just think of that when you're doing LCD or LCM. Okay, you can always buy bigger pants and wear belts, but you can't buy small pants and then jump off the cupboard and hope for the best.
Right. You try to find the smallest number that they'll all fit into. And so like the smallest pair of pants that you can find that everyone will fit into is the analogy that I think Ms. Anya is, and that's a good one. Okay, so for A10, I think a lot of you are getting there. So the answer is going to be 1 over 2 is the same as 12 over 24. And all I did was divide by 12 on the bottom and divide by 12 on the top. Let's see what other answers. For 5 over 30, what's 5 over 30 the same as? So to get from 30 to 6, what do I need to do? I divide by 5. And so I need to do the same thing to the top, which gives me 1 over 6 here as well. Can you do A12? So what's 7 over 14 the same as if you have a 2 as the denominator? So we divided by 7 on the bottom. So it's just going to be 1 here. So it's 1 over 2. So these are called equivalent fractions. 12 over 24 is equivalent to 1 over 2. And that's an important skill that we'll often use. Sometimes we'll change one fraction to equal another, and it looks different, but it's the same value. I can keep making, if I keep doubling, I'll keep making equivalent fractions to a half. Now, B is a little bit more tricky. And this is where Ms. Anya was talking about her analogy of pants. So what is the smallest number that both 15 and 5 can go into? And so I want to see, have we seen the answer in the chat yet? What's the smallest number that 15 and 5 go into? So 15 and 5 both go into 15. And so that would be our lowest common denominator for number B10. Okay, what about B11? What's the smallest number that 2, 3, and 6 go into? Okay, I see some answers in the chat. So what do 2, 3, and 6 go into? They go into 6. You're on fire, guys. So 2, 3, and 6, the lowest common denominator from this fraction, and I'm going to use it in a question now, is 6. What about this one? What's the smallest number that 4, 18, and 6 go into? Okay. It is 16. You guys are spot on. Okay, now I'm going to create a question. I want to create a question using this idea that we've just done. I want you guys to now add up, and I'm going to call this C10, C11, C12. I want you to add up the two fractions. So what is 13 over 15 plus 4 over 5? What is a half plus 2/3 plus 5 over 6? And what is 3 over 4 plus 5 over 8 plus 7 over 16? So I've changed the question, but I'm going to use the same skill that I used before. So it's over to you students again. You're going to use what you figured out in the last question, and then we're just going to call them C10, C11, C12. Okay, be careful, Lungelo, because you've added the denominator. What you've done is you've added these two, but your denominators are not the same. When you add two fractions, they need to have the same denominator. So you need to change one of them. You probably need to work with the second fraction and think, how can I add these two fractions? What we worked on in previous lessons is we said, let's make them both the same fraction as the lowest common denominator was 15. And so in order to get my 5 to 15, I times that by 3. But if I times that by 3, then I multiply that by 3. And so my equivalent fraction is going to be 12 over 15. Now I can add those two together because they have the same denominator. And so this is going to be 25 over 15. So the key thing I was checking here was, can you, now I see a lot of people have simplified it further. You're right. It's the same as 1 and 10 over 15 if you wrote it as a mixed number. So I'm not going to say more for now. I want you to do 11 and 12 as well. I don't want to steal your thunder, guys. I want you to experience the joy and fulfillment of flying solo here. So the only warning I'm going to give you is when you see something like 11, when you see this one, notice how the denominators are all different. So you're going to have to change these so that they have a common denominator. That common denominator, it would make sense to choose the lowest common denominator, which you worked out for me earlier. You said to me it was 6 for this question. So use that idea to help you. Okay. Oh, let me just turn my phone off. We don't want irritating pings going on in the background.
So just while the students are working at it, I know you guys are working really hard. Fractions are not exactly easy, but you guys and girls are welcome to reach out to me in the chat if there's anything you want to ask me. Also, I have got swift fingers, so I can type quickly and all that while Sir explains. So that's why I'm here. So don't be shy to ask me. It allows Sir to carry on with the lesson.
Totally. No, so me and Ms. Anya are a team, so we're looking to help you as we go. What I'm going to do now is I'm going to force all these fractions to have the same. I'm going to make equivalent fractions. Remember equivalent from the beginning of the lesson? Going to make equivalent fractions, and I want the denominator to be 6. So I times by 3. But then in order for it to be equivalent, I must also times the top by 3. Then for the next one, I'm going to times the top and bottom by 2. I'm using the dot as the multiplication symbol. So I get 4 over 6. And then this last one, I don't actually need to do anything. It stays the same because it's 5 over 6. Now I go 3 plus 4 is 7, plus 5 is 12. And I get 12 over 6, which gives me an answer of 2. Okay, so that is for the second one. Now the last one we have to do is this one over here, 3/4 plus 5/8 plus 7 over 16. And I want to give a bit more time for that. And then while we're waiting, if there are any questions from students, now is a good time to pop your hand up and ask. either in the chat or Sisipo, go ahead.
Hi, sir. I joined a bit late. Are we doing equivalent fractions?
We're doing part of it is equivalent fractions. What we're doing is we're adding fractions with different denominators. But as part of that process, we are using the idea of equivalent fractions. Does that make a bit more sense?
Yes. Thank you.
Cool. Pleasure, man. Okay. I'm going to get rid of this just so it's not distracting. So what we're going to do now is I'm going to say, put an equal sign. In order to make this in order to make the 4 have a denominator of 16, I need to multiply by 4 and 4. Over here, I need to multiply by 2 and 2, and here I don't do anything. So my equivalent fraction is 12 over 16, then it's 10 over 16, and the last one I don't need to make an equivalent fraction because it already has the denominator I was after, the lowest common denominator. So now, once the denominators are the same, or the Latin is the family name is the same, we can add them. So it's going to be over 16, but what's 12 plus 10 plus 7? It's 29. And then that's an improper fraction, which we could leave as is, or if we wanted a mixed number, we would say, well, 16 goes into 29 once, but how much is left over? So it's 4 to get to 20, and then another 9. So 13 over 16. And that shows you a couple of skills. It's the lowest common denominator, it's the equivalent fractions, and then it's the whole process we follow. Now, I'm going to take more questions because I see some of you are asking it, but I just want to check, can you go from improper fractions to mixed numbers? So I'm going to call this D, and I want you to do D10, D11, and D12, and your goal is to write this as a mixed number. And I just want to see that you have the skill, because the skill is part of the story of fractions. Ms. Anya, anything from you that I'm missing in the chat? Or
no, just one thing I want to mention from you don't have to scroll up also, but in the previous question where So went from 29 over 16, then he got a 1 and 13 over 16. Just remember to check always, because sometimes when you go from an improper fraction to a mixed number, that sometimes, even though you do that correctly, sometimes that fraction in the mixed number, let's say, for instance, let's say it was 1 and 12 over 16, just for the sake of it.
Yeah.
You still need to technically simplify that as well. Even though Sir hasn't written it, it's a good habit to simplify. So just always make, if you can, just make sure you can. And then earlier I saw a hand up, but it's went down again. So if you have any questions, please raise your hand so we can help you.
Yeah.
Excuse me, meneer. I'm just gonna be load shedding now. I have to go. So see you guys.
Dis
Bye.
reg. Alright, recorded. Bye-bye.
So for D10, I see the answers are coming through. So 5 goes into 23 4 times, and there's 3 left over. Then also that 3 left over is still divided by the 5. And then 18 over 3, what's that going to be the same as? Give it a moment more. What is 17 over 5 the same as? Rebetswe, what is your question? Go ahead.
So what must you do in number C?
Number
D.
D.
Yes.
We're just trying to write it as a mixed number. So 18 over 3 is actually just going to be the number 6. So we're just testing the skill of going between improper and a mixed number, because these are also equivalent numbers, but sometimes students get confused between when the number looks different, even though they're equivalent. So the last one we want to do is 12. What is 17 over 5? So if I count out how many 5s go into 17, 5, 10, 15. So I get 3 lots of 5s, but it's still something left over. Okay, Karabo Atlichang. I think you're on the right track. So 3, and then you get 2 left over, and you get 3 and 2/5. Okay, cool. So guys, we're getting there. We're getting there, but we just need to keep building on top of this. So what I want to look at quickly is, I say that word quickly a lot, don't I? Let's go from the beginning now. Let us add and subtract these fractions and make sure we know what the rules are for adding and subtracting. And then we're going to do multiplying and dividing after that. And then after, we're just going to keep going back to it and practicing. So I'm going to ask everyone now, you are going to do for me a selection of these questions, the ones that I circle. You are going to do number 7 for me. You are going to do number 9 for me. You are going to do number 11 for me, and you are going to do number 12. I want you to try and add these fractions or subtract them depending on the question and get the answer, and then I want it in the chat. And I want you to use the skills we've been practicing so far today. Okay, and then after we finish this question, we'll have a short brain break. While students are working on this, I would love to take your questions though, for those students who feel like they would like to ask a question.
But also, before we take questions, just to remind students, remember when we add or subtract fractions, it's something we need to do first. That's all I'm going to say. Or you must think carefully. All right, any questions you can... Oh, it's now 25 past 5. If anyone needs to ask a question, please raise your hand so we can help. Pumuzile, you can unmute yourself.
Yeah, go ahead.
Sir?
Yeah.
I'd like to ask, sir. So in order for you to minus or either subtract, we have to either make the denominators the same to just, we have to make the denominators the same in order to minus it, because you can't minus it like that.
Yeah, so this is very important. You're asking a very, very good question. When I'm adding or subtracting fractions, you cannot add or subtract fractions unless they have the same denominator. So if we're looking at number 11, the one denominator is 5, the other one is 3. This cannot happen. The only way it can happen is if you use your knowledge of equivalent fractions to make the fractions equivalent, but have the same denominator. Once they have the same denominator, but they're equivalent, so with the same fraction, they just look different, then you can subtract them using the method that we do previously. Okay, so does that help a little bit? It's very important. When we multiply or divide, we use a different process. And so that's the key objective today, is for students to get comfortable with these 2 different processes that we have to master for common fractions.
Thank you, sir.
Pleasure. Who else is out there who would like to ask a question?
Elvis had their hand up and then it dropped again. So I don't know, Elvis, if you still have a question or not.
Okay.
Scarlett, you can unmute yourself.
Sorry, sir.
Go ahead. Yeah.
I got a little bit lost.
Okay. Which question are you a bit lost on?
So I'm looking at number 7 and it says 2 over 4 plus 3 over 6.
Okay. Let's do it together because I was about to do it. If you look at this, the main first thing that we have to deal with are these denominators. They're not the same. So what do 4 and 6 both go into? We need a common denominator. And some of you may go for 24, but the lowest one is 12. Both will work. Okay, so the other thing to say is I've been obsessing about the lowest common denominator. It will still work if you get 24. It's just that that process breaks down if you multiply fractions as your default method. It breaks down pretty quickly when the fractions get bigger. So I'm going to suggest you have to first identify that 12 is the lowest common denominator for this question 7. Once you've done that, you now need to change these fractions to have denominators of 12. And the way I'm going to do that is that I'm going to multiply this by 3 and that by 3 And then on this side, I'm going to multiply by 2 and by 2. What that does is it forces both these fractions to have denominators of 12. But in order for this to be an equivalent fraction, the top is affected as well. So I get 6 over 12, and I get, wait, 2 over 4. Oh, yes, I do. And 6 over 12. Now, some of you may spot this. It's just a half plus a half, or you're going to get 12 over 12, which is the same as 1. And when you think about that, it makes a lot of sense because 2 over 4 is a half, 3 over 6 is a half. What do you get if you add 2 halves? You get 1. So I don't know if that scholarship that helped, but that's the process I would be using to do the other ones. So for number 9, we have to deal with the 9 and the 3. Okay, I see the answers. Legan's got answers coming in. And for those who are on fire, you can also do the ones we haven't done. I haven't circled. We've got a little bit of extra time. Okay, so for number 9, the lowest common denominator is going to be 9. And so the only thing I have to touch is I need to multiply that by 3 and that by 3. And then the question becomes 7 over 9 plus 6 over 9. And then the final answer is going to be 13 over 9, which is an improper fraction. If I wanted to write it as a mixed number, 9 goes into 13 once, 4 left over like that. Okay. Then for number 11, this is subtraction. And for 5 and 3, the lowest common denominator is going to be 15. And so I need to multiply this by 3 and that by 3, and this by 5 and that by 5. Guys, notice how if I multiply the top and bottom by the same number, the fraction is still the same fraction. That's a really important idea. If you do the same thing to the top and the bottom, the fraction stays the same. It's the same value. It just looks a bit different. So we get 9 over 15 for this, minus 5 over 15 here. Let's just check that. 3 times 3 is 9. 5 times 1 is 5. And so we're left with 4 over 15. And then the final one, this last one is a bit more tricky. 8 and 3, what is the lowest common denominator that we get for that? I think in this case, the lowest I can think of is 24. Because 3, I go like 3, 6, 9, 12, blah, blah, blah. In my brain, and I know my times tables quite well, unless I've missed something obvious, 24 is the lowest we can get. So I'm going to multiply the 8 by 3 to get to 24, but I do the same at the top. And then here I multiply by 8. And so then I'm going to get 3 times 7 is 21 over 24 minus 16 over 24. Let me get rid of all the other stuff that is distracting to the students. So if I get to that stage, I've got the denominators that are the same, which is awesome. And so what's 21 minus 16? It's just going to be 5, but it's not 5 by itself. It's just 5 over 24. Okay, guys. So I think, Miss Anya, if I could just come back to you, are the students, are we generally getting the hang of plussing and minusing here? Okay?
So what I find in the chat is a lot of us, we are fine of finding the LCD or a common denominator. So I see some students tend to find a larger common denominator. That's fine, because when you simplify, you'll still get to the same value. But I think an error that I noticed in the chat as was even though students find the LCM or common denominator, they forget to multiply the top. So for instance, at number 11, we can see the common denominator is 15, but then they'll say, all right, 3 over 15 minus 1 over 15, instead of converting the numerators as well.
So I think this is really important. I think that we have to make sure we do this equivalent fraction step. I'm just going to focus on this for a second. I'm going to get a different color just to really drive the point home. So when we started out, we had 8 and 3, and we went through a transformation. We changed the denominator to 24 down here by timesing the bottom by 3 and the top by 3. The 3 times 7 is how we got the 21. So that's a really important thing. And then we did a similar thing with this fraction over here, where we went 3 times 8 is 24, but 2 times 8 is 16. Now, we have to get to the stage where we have denominators are the same. And now, only now can we subtract the 2 numerators. Let me use a different color for that. Right, so only now can we go 21 minus 16 to give me my 5. Okay, guys, I think that you do need some more practice on this, but I do also want to touch on multiplication and division tonight. And so I'm going to take a break now. And when we come back from the break, we are going to look at multiplication and division. And so what I want is I want everyone to stand up for a second. You know the drill. And I'm going to grab a pen. Today we're going to be doing pen flips. I want to please make sure that you are in a space where you can not whack into something. So you have your pen and you're holding one side. And what you're going to do is you're going to try and toss it and catch it on the same end. Oh, I was horrible that time. Not only are you trying to catch it on the same end, but you only want it to spin in the air once and then catch it. Let me try if I do it the other way around. Oh, that was pretty good. Try again. I'm a natural again. I'm actually better with my left hand, which is strange. Oh, that wasn't good. So you know the idea. See how good you are at pen flipping. I want to observe the students doing this. So can you turn your camera on, guys, and then I can enjoy seeing how good you're getting. Tebogo does look promising. I like what I'm seeing. Sisipo, let's see what you can do. Do you have the fine motor control necessary to execute such a difficult thing? Tebogo, let's see. I see some potential there, looking good. Didi?
Is this right?
Scarlett's not bad.
It's Sisipo that spoke, sir.
Oh, is it Sisipo? Trevor's okay, not bad. So it's funny how much. Oh, sorry, it's funny how much control it takes to do this, and I do love it as an activity to just zone out. And Zizou is not looking bad in terms of being able to do it. Okay, guys, well done. You can go back to your seats now. And I do hope, if you feel like your brain relaxed a little bit when you were doing that, give me a thumbs up. If you feel like, yeah, it didn't really help me relax, give me a thumbs down. I want to see the chat. Was it helpful? Did you feel like you unwound, you like got your brain off maths for a bit? Thumbs up. If you think, yeah, there's better ways to do this, give me a thumbs down. I would love to see the experience of the students. You know, that's been my experience in class too. Like it's amazing how your brain has to focus on that task. And so it has to let go of maths, which I think we all need sometimes when we've been concentrating really hard. Okay, let us return to then the second part of the lesson. The second part of the lesson deals with multiplying. Okay, we're not going to do the mixed number thing now. I want to work on multiplying fractions. Now, the good news is when we multiply fractions, we don't actually need to have the same denominators. Now, In the first one here, it turns out they are the same, but in the second one, they're not the same. And when we multiply fractions, all we do is we multiply the numerator with the numerator, and we get 4, and we multiply the denominator with the denominator. So we would get 4/9 in the first one. Or in the second one, we would get 3 times 4 is 12, and 5 times 6 is 30. But we could simplify that further. I'd love to see in the chat, what can 12/30 be simplified to? Could you pop that in the chat, guys? What can 12/30 be simplified to as an equivalent fraction? So what's the biggest number that goes into 12 and 30?
Wouldn't it be 3/5?
It wouldn't be, I don't, let's have a look. You got to find a number that goes into both 12 and 30. Or what you could do is you could keep dividing it by numbers. So let's see. If I went divide by 2, I'd get that. But then I could also divide the top and bottom by 3, which would be 2/5. So you can get down to 2/5, I think. Let's just see. Let's just check that my adding is right. So I divided by 2 and by 2, and then I divided by 3 and 3. As long as I do the same top and bottom, now I can't go any further than that. So 6/15 is the same as 2/5. So those are equivalent, but I just wanted to get that skill going. All right, now the main goal is to practice our multiplication skills. So you guys are going to multiply these fractions for me. The ones 5 to 10, and then you're going to put your answers in the chat. And this is going to be a speed round. So you've got until 1744. So let's see those answers. If we're multiplying fractions, what do we get? So the first one indeed is 5/8. You're quite right. And you can't simplify that any further.
So we have a hand from Pumazile.
Pumazile, go ahead.
So, sir, remember when I spoke to you earlier and you told me that addition and subtraction, you need to get the denominators the same. But here in this case, do you just multiply as it is and simplify?
This is really, really important. And that's why I did them so separately. When we're multiplying fractions, you don't need to worry about this idea of the same. You can literally just multiply the top with the top and the bottom with the bottom. And that's a very different way of doing it. And so in your brain, you have to separate multiplying and dividing versus adding and subtracting. And you'll see when we do mixed questions, knowing when to do what is an important part of the program. So thanks for the question.
So can I add on to what Pumuzile has just asked?
Please do.
But I'm going to, so the kids can actually see my face. Just give me a
Go
second.
No, I pressed that.
So just remember, we're just going to add on to what Sir said now. So, so adding on to what Sir said now. So remember, we can't add apples and pears. So when you add or subtract fractions, we first need to get a common denominator. So that's the root. So when you add or subtract and the denominators are not the same, you first need to change the denominator, right? So you have that rule in your head. Then you go on to the second thing, okay? So now we are multiplying, okay? So just carry on with the calculations. I'm just explaining. Perfect. So how I like to explain multiplication, it's like a marriage. So in multiplication, it doesn't really matter what your surname is, right? Because after the marriage, you're gonna either combine your surnames or something. So that's why Sir says you can just work from left to right. So I always see marriage as like multiplication. You know, it doesn't matter what your surname is. Surname obviously being the denominator. That's how I explain it. And then division, we're gonna get to division now. But division is where we use KFC. Okay, so
Yeah.
I hope that summarizes it very well for you. All right,
No,
back
that's
to
a
you,
useful
sir.
way of that's a useful way of thinking about it. Thank you. So 12 over 40 can be simplified further. And I think that if I divide 12 by 4, I get 3, and I get 3 over, and then 40 divided by 4, so 3 over 10. Is that right? Yes. Yes. So there's that one. Then this one is going to be 12 over 12 over 12, which is 1. And then I only gave you up to 10. Hey, I didn't give you anything more than that. So
No, just up to 10. Otherwise, we can't really see the questions.
no, that's fine now.
And then, so while I'm unmuted, Imad, yes, there's a quiz at the end of every Wednesday lesson. So just stay on the call. When Sir's done with the lesson, then I'll release the link. Okay,
Okay.
right back to you, sir.
So I've got 25 over 48. I don't think that can be simplified any further off the top of my head. No. That's
Think I must get a R5 every time I resume the lesson.
No, I know, but it's just funny because I never quite understand what shortcut is being involved. Like,
No,
anyway,
I don't know.
Okay, 42 over 16 is 16 goes into that twice with how much left over? 10. And then in theory, we could simplify that because 10 over 16,
5 over 8.
5
Yeah.
over 8. So basically you halve
Dividing by 2.
2. Let me just.
Yeah. So while you do that, I see we've got a hand from Tubelichle.
Yeah, Tubelichle, go ahead.
Hi, sir. The question I have is from question 9.
Okay.
I want to know why you couldn't simplify it even more.
Okay, good question. What I checked in my brain was, are there any small numbers? Now, the problem with this one is 25 is an odd number and 48 is an even. So really, I can't do 2. Then I tried 3, and 3 goes into 48, but it doesn't go into 25. None of the even numbers will work. So then I have to try 5, but 5 doesn't go into 48. Then I have to try 7. So basically, there were no numbers that could break down the 25 and the 48 at the same time. And that, whereas if I look at something like 40, because they're both even, I could, I could have halved them and got 20, and then I would have gone, oh, I can halve that again. It's 3 over 10. So I'm looking to see, is there a common factor in both of them? Is there a number that goes into both of them that I can divide by? Does that help a little bit?
Yes, thank you, sir.
Okay. All I want to do is I want to finish the lesson with a little bit of practice on division, and then I'm going to let you go. Okay, because I think time is almost up. And if we look at something like this, if we look at a division question, the only thing, and Miss Anya used the idea of KFC, but and that's a perfect way to remember it. But all we have to do with division is we take the first fraction and we keep it where it is. So 3 over 5. Now, we don't carry out division, all right, in the way we convert division to a multiplication, and we make an adjustment so it stays equal. So it's still an equal sign here. So what we do is we go 3 over 5 and we change the division to a multiplication, but we can't just stop there, because if we just changed it to multiplication, then we've changed the question. So we make an adjustment and we flip the 7 and the 2 over. Now, if we work out the answer to this question, it will give us the answer to the original division. And so we're using that link. And so what we do is we just say now 3 over 7 is 21, 5 times 2 is 10, and my answer will be 21 over 10. And so what Ms. Anya used was, and Ms. Anya, jump in if I'm doing it wrong, you keep the first fraction the same. So 3 over 5 stays the same. You flip the second fraction, which is one here, and then you change the sign, which is the thing over there. Now,
that's correct.
And what I want to do is I'm going to make this 2 over 1. And I'd like you guys to finish the lesson. I'm going to make this 4 over 1, because that's a trick you can often use with fractions. And I want you guys to work out 6, 7, and 8 for me. So give me the answers in the chat for 6, 7, and 8. What's a half divided by 2? And then I've given you a little sneaky cheat here that 2 can actually be written as 2 over 1. What is 7 over 12 divided by 4 over 1? And then the last one, use the cheat 6 over 1, because anything over 1 is itself, divided by 4 over 5. And then while you're doing that, I will take some questions.
So Imad's hand is up.
Imad, go ahead. Imad?
Okay, no, I think they dropped it. Imad, if you want to ask something, just unmute yourself, okay?
Yeah. So I want to see the answers in the chat, and then I'm going to send you off to do the quiz. So let's see those answers. Okay, so for the first one, a half times 1 over 2 would be the adjusted fraction, and then you get a quarter. Okay, so for number 6, you get a quarter, because you keep the half where it is, you flip the division to multiplication, well, you change the division to multiplication, and you flip the second fraction, which was 2 over 1 to 1 over 2. Okay, let's do 7 and 8.
So we've got a hand from Pulela.
Pulela, go ahead.
Pulela, you need to unmute yourself now. Okay, no, the hand is dropped.
Okay. So the second one, we need to do this intermediate step. So 7 over 12 times 1 over 4 is the same as 7 over 12 divided by 4 over 1. And so what do we get? We get 7 over 48. Now, we can't simplify that any further. Then what's number 8 going to be?
So just to reiterate, in other words, put emphasis on what Sir said earlier. So if you're given a whole number when you're doing fractions, so like for instance, question number 6, question number 7, question number 8, if there's a whole number in your sum, you really do not need to stress, because any whole number can be written as a fraction simply by rewriting it over 1. Because 100 is the same as 100 divided by 1, because fractions are essentially just division symbols that are written in a different manner. So so if you see a whole number, if you just write it over 1, you've already changed it to a fraction without changing the actual value. So you are allowed to do that.
Totally. Okay, let's do the last one. So we get 6 over 1 times by 5 over 4, which then gives us 30 over 4. And then, what do we have? Oh, my Zoom thing has just jumped in the way. 30 over 4. And then, so we divide by 4. How many times does 4 go into 30? I think it goes 7, because I know my times tables. And then I get 2 over 4. And that actually can be simplified even further if I to 7.5. Okay. So guys, I think that on our lesson next week, Wednesday, what we're going to do is we're just going to do all of these combined. So basically, we're going to do adding, subtracting, multiplying, dividing, but we're going to mix the questions together. So you have to remember what approach gets used with what fraction. And then Miss Anya, if I could ask you to please put the link to the quiz in the chat. So from now, I'm going to ask students to go off and do the quiz and to show kind of your understanding in that quiz, but also enjoy it. It's just a formative quiz. It's just meant to be for consolidation of your learning.
And then, so as I'm typing in the link, there's some news I'd like to share for class. Do you think I
Yes.
must do it now?
I do think so. Yes, yes.
Okay. So before you guys, I'll send a link to the quiz. But before you hop off, this is officially my last lesson with you guys. So I'm finishing up with Watobe this week. I've got a bit of other jobs that I need to focus on in that. But it's been such a lovely time working with you all, and I thoroughly enjoyed it and learning with you guys and from you guys as well. So yeah, us as teachers, we also learn, yeah. So unfortunately, this will be my last lesson with you guys. But you guys have been a great bunch, and I wish you guys all of the best.
Miss you, Miss Anya.
No, man.
I'm
Miss
sorry,
Anya,
I'm also
Anya-
sad.
Miss Anya